Welcome back to my channel Ultrasound Whispers. Today we will discuss parameter of pulses. As we discussed in early lectures, the parameter of ultrasound waves. These parameters are a little bit different from those. Let's start. How does it go? So pulse wave, we have already discussed. We know that the two or more cycles that travel together are called pulse waves, and there are two components of the pulse waves. So what are those two components that are on time and off time? And we discussed before that if a transducer produced a pulse, I think it's very large pulse. Let me make it very short and let me make me a transducer. Here is a transducer, and this transducer produces a pulse. And after producing the pulse, it becomes silent. And it doesn't produce the second pulse until and unless it receives the echo of this pulse. So when a transducer is producing a pulse, that is called on time. Or we can say that the transducer is in transmitting mode or in talking mode. And when the transducer is silent, this period is actually called receiving period. In this period, it receives the echo from this pulse. And this silent period or receiving period is also called off time. So after sending a pulse, transducer waits for the echo. When it receives echo, it produces the next pulse. So a pulse has two parts. Number one, on time and off time. And off time is actually the time in which a transducer waits for the return of the pulse, and when pulse is returned, it translates into a meaningful information. So remember that until and unless the echo is received, the second pulse is not produced by a transducer. So ultrasound imaging, mostly the pulses of 2 to 4 cycles are used. These are called short pulses. Short pulses mean, what is meant by the short pulses? Short pulses mean high frequency. High frequency. And high frequency mean high resolution. High resolution mean good quality image. Once again, you need to remember that high frequency of short pulses trade off between penetration, and these short pulses have high resolution but low penetration. So that is always be in your mind, that a resolution is trade-off between penetration. Again, 2 or more cycle is called a pulse, and 2 to 4 group of cycles are used in a. So parameter of the pulse, there are some parameters of the pulse that are called pulse duration, spatial pulse length, pulse repetition period, pulse repetition frequencies. So these are the 4 parameters that we will discuss one by one. Pulse duration, time from the start of a pulse to the end of the same pulse. Remember, this is our pulse, and time. Remember, pulse duration is a time from the start of the pulse to the end of the same pulse. Start of the pulse to the end of the same pulse. This is time. Time to create a pulse is called pulse duration, and it is also represented by PD. P mean pulse and D mean duration. Duration mean time. So what you need to remember, the duration. Duration mean time. So the pulse duration is also called on time, talking time, or transmitting time. And you are also familiar with that when actually the pulse is being produced is called pulse duration. The time in which actually the pulse is being produced is called pulse duration, and when pulse is being produced, that is called on time. And in which there is no production of pulse, transducer is silent, this is called off time. And in pulse duration, only on time is included, off time is not included. Remember, this is the point to be remembered, that on time is actually the time in which the pulse is being created, and not the time in which the pulse, there is no pulse, there is a off time of the transducer. So this is the time, so its units are millisecond, microsecond, or second. So usually microseconds are used in ultrasonography. So pulse duration is decided by the source, and sonographer cannot change it. So pulse duration cannot be changed by the sonographer, and it is only decided by the pulse. So we have already discussed this, and this concept is very important to understand the parameter of the pulse, that the actual time in which a pulse is being produced is called on time. And the time in which transducer is silent and waiting for the reflection of this pulse is called off time. And after off time, the next pulse is produced. So off time when transducer is silent, and on time when it is actually producing a pulse. And you know that on time is also called pulse duration. Pulse duration and time period and frequency. Pulse duration PD is equal to number of cycles multiplied by time period. So time period can be represented by capital T, and we have already discussed in the previous lecture about the time period. So pulse duration and time period is also, in the previous lecture we discussed that the time period is reciprocal of frequency. So time period is reciprocal of frequency. So in this formula, pulse duration is equal to number of cycles per multiplied by time period. Time period, you can write it like this: number of cycles. Number of cycle mean number of cycle in a pulse multiplied by 1 over f pulse duration. It means the frequency of the pulse increases, the pulse duration decreases. Or you can say that when the pulse duration increases, the frequency increases. Sorry, frequency decreases. If small time is taken to create a pulse, it means the pulse duration is low and frequency will be high. And if there is a large pulse, it will take more time to create. So pulse duration will be high and frequency will be low. So this is a larger pulse and this is a smaller pulse. Smaller pulse with the potential with pulse duration with low pulse duration, and larger pulse with high pulse duration, and pulse duration is inversely proportional to the frequency. Let's move forward. And short pulse duration means short pulses. We have already discussed that a short pulse will take short pulse duration, will take less time to be created, so its pulse duration will be short. And if a pulse is long, it will take long time to be created, so its pulse duration will be high. And when pulse duration will be high, you know that pulse duration is inversely proportional to the frequency, so frequency will be low. So the pulses that have low pulse duration have high frequency, and high frequency mean high resolution. So we need pulses of low pulse duration time for our ultrasound imaging, and short pulses have low pulse duration. Spatial pulse length. It is similar to the somewhat wavelength, that spatial comes from space. So the distance or the space occupied by a pulse, the space occupied by a pulse, occupied by a pulse is called spatial pulse length. And it is understood that a small pulse will occupy small space, spatial pulse length. It says high spatial pulse length, and it has low spatial pulse length. Because why? Because it's a short pulse, and short pulse is occupying small area, while this is a large pulse and it's occupying a large area. But in ultrasound imaging, we are interested in small pulses. So the pulses that have small spatial length, small spatial pulse length, are needed in ultrasound imaging. They are our favorite. The pulses that have small pulse duration and pulses that have small spatial pulse length, they are required, and they have high frequency, and high frequency mean high resolution, but with the trade of penetration. So distance distance from the start of a pulse to the end of the same pulse is called spatial pulse length. So it's a length or a distance, so its units are millimeter, meter, millimeters. So both source and medium determine pulse length, and sonographer cannot change it. So the medium and the source decide what will be the spatial length, what's going to be the spatial length, and it is like a wavelength. That wavelength is also decided by the source and the medium. And sonographer cannot change neither wavelength nor spatial pulse length. So what is the difference between spatial pulse length and a wavelength? So wavelength means the wavelength of the pulse. So the formula is cycle, number of cycles multiplied by wavelength. It's represented by lambda, and it is called spatial pulse length. You know that spatial pulse length, number of cycles, this wavelength, we know that it is equal to 1 over frequency. So you can put the value of lambda here, 1 over frequency. So now when spatial pulse length will increase, the frequency will decrease. And when spatial pulse length will decrease, frequency will increase. And what is spatial pulse length? Spatial pulse length is the distance from the start of the pulse to the end of that pulse. It means greater will be the distance, larger will be the pulse, and lower will be the frequency. And smaller will be the pulse, higher will be the frequency. So this is the relationship between the spatial pulse length and wavelength and frequency. So we always need short pulses. So short pulses of small pulse duration and small spatial pulse length. So spatial comes from space. Space means the distance or the place that occupies a pulse. So we have already discussed this. And short spatial pulse length means short pulses of high frequency. Pulse repetition period. What is pulse repetition period? Pulse repetition period is time to start of one pulse to the start of the next pulse. Look. Here is a pulse. And here is another pulse. And we know that when a transducer generates a pulse, this is called on time. and it's also called pulse duration, the time to create a pulse. So, and after that, transducer becomes silent, and this is called off time. Now the next pulse will, this second pulse will not be produced until and unless echo is received. Echo of this pulse is received. So time from the start of a pulse and to the start of the next pulse. So this is the start of the first pulse, and this is the start of the next pulse, of the second pulse. Remember, we are talking about the time. So the time in which a pulse is being produced, and the time in which the transducer is silent, and again next pulse, the time for the production of the next pulse. So this on time, what does this pulse repetition period says? The time start from one pulse, start from one pulse to the start of the next pulse. So the two types of times will be included. Number one, on time plus off time. So you will pass the on time and off time, then the second pulse will be started. So this is called pulse repetition period, that it comprises on time and off time, and start of the one pulse to the start of the next pulse, and it includes off time and on time. Hopefully you would have grabbed the concept. On time plus off time. Off time in listening time. So these both, when you divide both of these, on time and off time, you get the pulse repetition period. And it's as it is time, so it has the same units, that units of time, millisecond, microsecond. Pulse repetition period is directly proportional to the imaging depth of the view. We will discuss in a little bit later how imaging depth affect the pulse repetition period, and it is also decided by the source, and sonographer can change it. Pulse repetition period is changed by the sonographer, because we said that pulse repetition period is directly proportional to the imaging depth or depth of view. So when a sonographer changes the depth of the imaging depth or depth of the view, he is actually changing the pulse repetition period. Let's see how does it goes when depth is changed. So imaging depth changes the listening time or the off time. So if you see that here is a knob, this one, and it says depth. So on the console of the ultrasound machine, a sonographer can change the depth of view or scanning depth by moving this knob according to its according to the requirement of the scan. And this is cardiac scan, you can see the cone-shaped image, and the top is showing that this image is created by the cardiac transducer, and here is the depth scale. So here it is the depth of 10 centimeter, and here is the depth of 15 centimeter. So when you will move the knob on the console, so here the scale will change, and the scanning depth, if you keep the scanning depth 10 centimeter, then you will be able to see this portion of the image. So the scanning depth, how does it affect the pulse repetition period? Let's see. And pulse repetition frequency is the number of pulse produced by a transducer in 1 second. Suppose here is a transducer. In 1 second, it produces three pulses. So its pulse repetition frequency will be 3 Hertz. If this transducer produces 2 million pulse in 1 second, its frequency will be 2 megahertz. So pulse repetition frequency is the number of pulses produced by the transducer. Transducer is called pulse repetition frequency, and this pulse repetition frequency is different from the frequency of the pulse, and it has nothing to do with the frequency, no matter the pulse is short or pulse is long. Pulse repetition frequency is the number. Is the number of pulses in 1 second. This is called pulse repetition frequency. And a sonographer can change pulse repetition frequency by controlling the depth, as he can change the pulse repetition period. We will see a little bit later. So number of cycle in a pulse doesn't affect pulse repetition frequency. So it has the same unit as of frequency. Pulse repetition frequency is inversely proportional to the imaging depth. Pulse repetition frequency is inversely proportional to the imaging depth. It means if you will increase the imaging depth, you will decrease the pulse repetition frequency. Sorry, this will go in this, and this will go. And if you decrease the imaging depth, the pulse repetition frequency will be high. So, this imaging depth means that at what distance or at what depth you are scanning. Pulse repetition frequency is again decided by the source, but a sonographer can change pulse repetition frequency by adjusting the imaging depth or depth of view. Let's see how this goes. So we have a transducer here, and it produces a pulse, and it got reflection from this organ and it receives its echo. And here is another transducer that also produces a pulse, and this pulse goes to the kidney, and it will not produce the second pulse until and unless it receives its echo. So what do you think that which pulse is covering more distance, pulse 1 or pulse 2? Definitely pulse 2 is covering more distance as compared to the pulse 1. It means pulse 2 will take more time to reach its target organ, and similarly it will receive echo later or after a large time as compared to this one. So the pulse went, reflected back in a very short interval of time, but here the pulse went, it covered a long distance, it took a large time, and the pulse took a large time in returning back. So and this time we know that is off time, in which it has to wait its pulse. So the greater is the distance between the transducer and the target organ, it has to wait longer, so its off time will increase. So when you increase the depth, you scan a deeper organ, transducer has to wait more as compared to when you are scanning a superficial organ. And this is for the sake of argument, otherwise liver is not a superficial organ. Or you can say that the organ that is at lesser depth. So by increasing the depth, you increase the off time, and when off time is increased, the pulse repetition frequency is decreased, because it will create the second pulse after a long time, because the echo has returned after a long time. So in this way, when you increase the depth or decrease the depth, the pulse repetition frequency and pulse repetition period is affected. When the structure is less deep, the pulse goes quickly and comes back quickly, and it again produces the second pulse. But here it takes long time to return, and after a long time a second pulse is produced. So the pulse repetition frequency will be low in this case. So pulse repetition frequency and pulse repetition periods are inversely proportional. So if I write this, pulse repetition frequency is inversely proportional to pulse repetition period. If pulse repetition period will increase, pulse repetition frequency will decrease. And you know that pulse repetition period, what is the pulse repetition period? Pulse repetition period is on time and off time. And when you increase the depth, off time increases, And when off time increases, the pulse repetition period increases, and that will decrease the pulse repetition frequency. And this is called reciprocal relationship, that if one quantity increases, other decreases, and vice versa. What a sonographer can change and what cannot change. So you can make your the last two entities, pulse repetition period and pulse repetition frequency, can be changed by the sonographer. How he can change? Changing by imaging depth. Yes, these two parameters can be controlled by the sonographer. That is the other two, the two spatial pulse length and pulse duration cannot be changed by sonographer. So you say no, we cannot change this. So these are four parameters of pulses, and these are very important in ultrasound imaging, and you need to remember this very well. So this is all for today, and thank you very much for being with me. Please subscribe and like this video. See you in the next video.